Okay. Hello everyone, welcome to a brand new stream. Second stream I'm doing today. I was going to record this as a video. Today I'm going to show you guys how to do gradient color in number logic with the RGB block. So yeah, as you can tell, I already have this all built up already. Hold up. Sorry, I just have to fix my my live chat. Couldn't see anyone talking. There we go. There's Mr. Partisan, Matt Rope, Virtual Doodle, Mr. Mater, Mamf, Lopan45, Damian Thompson, Matt Pope. I think I said his name twice. How's everyone doing? I'm doing frustrated. First stream didn't go too well. So second stream, instead of recording this on a video, I'm just gonna explain the build and how it works. And yeah, I don't really know. Like, some people like the streams, some people like the edited videos. I have no idea. So we'll just do a live stream because I don't feel like editing. I've been through enough today. So anyway, this this gradient thing machine. Here, let me just go ahead and show you with a paint. There we go. We can literally paint. This is both of these blocks on the very side here. Those are the inputs. And then everything in between is going to be a gradient between the two colors. So I can paint this any color, and it'll just automatically update the entire gradient to be between any two colors. I've been around since Waterbot era. That's it's a long time ago. You got the wishbone from the leftover turkey. Nice, Mr. Partisan. Did you do the did you make a wish with someone or whatever? Did you get the bigger half of the wishbone? So anyway, and you know, if you played with RGB blocks before, you might know that they can take anything as an input. So like any number as an input, or or like another RGB block if you really want to. So over here on the side, I actually have an RGB block right here connected to a memory panel. So this memory panel, like, it just has a bunch of preset colors. That's all it is. So let's go ahead and paint. Okay, hold on. I want to fix my hotbar so I'm not constantly switching. Paint. I don't need a weld tool. I'm probably not going to need this. I don't know, I just like to have those tools. Yeah, so let's get, I guess, a gradient between yellow and some other disgusting color. Or the darkest yellow. I don't know. So, no, let's just go pink. Because I'm pretty sure I didn't save pink in here. Alright, so this, we'll reset this too. So again, this is just an example that you can connect anything into these inputs. RGB blocks can take a single number as an input, or 3 numbers for RGB inputs, or 3 numbers for hue, saturation, and value inputs. And there's more examples of those. Oh my gosh, how did I even do that? I didn't even jump that far. I'm a parkour god. So yeah, there's a... what even is this? What even is this? I don't know, to be honest. One. So this is a hue, saturation, value thing, I'm pretty sure. Okay. Anyway. Sorry, got a little distracted. So let's go ahead and you can already see the first color gradient. Maybe I should. Oh, that's a nice one. So yeah, you can just flip through any color, any inputs that you want, and it'll automatically create the gradient. So I'll explain how that works too in a little bit, but first we're gonna jump through all these examples. Steal a few more colors. When the colors are really close together, the gradient looks really, really nice. and then when they're like super far apart, oh, that's done. Okay, and when they're super far apart, it's like here. Let me see if I can show you actually the color that we originally started with. There we go. Okay, so you might be able to see there's like an optical illusion where, let's get really, really close. So where my mouse cursor is, this is like the left side of this block, and it seems like it's more pink than the right side of this block. But that's impossible because, well, it's a polygon block. It's all the same color. But just because of the contrast between the next color over, it makes it seem like this is actually lighter than this side. It's pretty cool. It's like there's just a visual optical illusion where each block is its own gradient. Anyway, it's only apparent when the colors are very opposite of each other. If they're super close, like this, you don't even see it. That's some weird visual glitches I'm seeing. So yeah, there's this guy over here, and there's this guy over here. And you might notice that they're just connected to a logic gate that has a counter block and then 2 zeros. Those are going to change to 1. And same with this over here, the absolute value. Absolute value of what? That's clearly wrong. It's not. The absolute value does nothing there. Whatever. Not important. So this test button, all it's doing is it has 2 RGB blocks. It's set to hue saturation value, like it's in HSV mode. So flicking this switch turns on 2 logic gates, which count up the counters by different amounts. As you can see, this one's painted orange, and this one's painted light orange. So this one's going up slower than that one is. So you're going to see the right side changing hues, cycling through all the hues of color much faster. And this way, it's just sort of a way to test sort of like all combinations of colors, color gradients. So an interesting part then about this gradient thing over here. You might notice this thing over here just like sitting. I included a way for you to extract any color that you see in the gradient. So let's say you see a fancy color right here. I want this color. Just connect it straight to that block, and bam, you get the exact RGB values for that color. Except now that the colors are constantly changing, so is this. So there's that. Let's go ahead and just stop that. And then they flick back to red. So yeah, we'll change you to purple, we'll change you to green, very opposite colors. And I'm extracting this very specific shade right here in the middle. And it spits out the RGB. And that's actually something that I'm using a lot. It's it's actually very similar to the hexadecimal video. If you've seen the number logic video where I explain how hexadecimal colors work, and how you can use the RGB block in different ways. I'm basically doing that right here. It's just this little patch of code right here. Patch of code, like I'm talking about number logic like it's code. But no, really all this does is it takes the number, the one single number, and just breaks it down into the RGB values. Very, very simple stuff. If you want to know how that section works, because I am going to be referencing it, again over here and again over here. So if you want to know how that works, definitely check out that hexadecimal video. Because you're gonna need to know how that stuff works when I get to explaining how this gradient stuff works. But yeah, this is just a very simple like module, let's call it. It just converts a single number to RGB. And you can do that, anything that you input into here. From anywhere in the gradient, you can get the RGB value. If you see a really nice color you like, that's what you can do. So this guy over here, it does require the test on function, I'm pretty sure. Ah, yes, I remember what it's doing. Okay, so what this does it's going to go through any color that you choose, which I suppose I should probably... Yeah, I should probably choose a better color. There you go. So I can just flip through the hues with this red setting over here. And I can also flip through the saturation as well. So let's... I kind of wish I had a display. I'm going to probably be able to display, hey, what's that? Delta Fuchs. Remember to leave a like on the stream. I can't leave a like on my own stream. Not until after it's processed by YouTube and I can watch it as a video. Or unless I visit my own stream page, I guess. Thank you for the 20 Nox, though. I call them Nox because I know there are Norwegian crowns, because the Norwegian people like to get their currency by murdering royalty, so they have all the crowns, and then they, you go to the market to buy a loaf of bread, and you're just like, well, I killed 13 princes yesterday, but I can only give you 3 crowns because I'm running low on... What am I even saying? let's just move on to the demonstration. Shall we? Alright, so this is hue 60 or something. That's hue 60. And then with saturation of 1, it goes to, max color, let's call it. But if I go to saturation of 0.2, you're going to see it comes out very, very gray, almost white. So there's hue, saturation, and for this test module up here, it's just cycling through the value, going just back and forth between 0 and 1. So it's just going to go... it's like increasing the brightness on a, you can change the hue, saturation, or brightness value. That's all it's doing. So full saturation is very vibrant colors, but it's going to go from black to vibrant color. I guess saturation is the amount of color, because now this is just going from black to white, no matter what the hue is. Yeah, and then of course you can you can do that and test with any color over here to see the gradient between any two colors. Whoops.
Don't try this yourself. It's
and let's go sort of like a light blue. See, now doing this partially makes me want to do like like a sky. Like I want to build a sky gradient sky gradient. I basically want to do an animated sunrise sunset. Looking at this, it's exactly what it makes me want to do. Except then I'm gonna need some like red in there, and we're gonna go. No. Sunrise is like an orange. And this goes to kind of like a bright. I don't even know. I don't even know. Anyway, so that's this test. I just have a bunch of test modules here on the side that you can just go boop, boop. Just to, to test your inputs. We don't need this anymore. This was just a bunch of preset colors. This was the slow hue cycle. This was the fast hue cycle. Okay, that's it. Those are all the tests. I'm pretty sure. Yeah. All right. So then, while I'm explaining this, let's get some, I don't know, colors that I know how to work with in here. All right. So how this works, are you ready for some bigger brains? I know this looks a little bit intimidating, but just like the 3D wave logic stuff, it's all the same thing, just repeated, one after the other. It's the same thing repeated. So don't worry about this looking complicated, because it's literally just one column. That's all it is, that's all the logic is. And then once you understand how one column works, you literally, like, you understand exactly how all the other columns work. None of these are connected to each other on the sides, like from side to side like this. So it's really, this is actually much simpler than the 3D wave logic stuff. All right, so we have the inputs, input left side and input right side. And just like I explained up here, we have the little modules to convert the single number. So RGB blocks, they can take in any number, but they can also transfer their color to other blocks. And they transfer it just through one connection like this, not through 3 connections like RGB. It's just through one connection. It's like an entire single number that carries the whole color information. But we're using that module just to split it up into the RGB values. And again, we have the RGB inputs here just to verify it is using the same color. It was just like sort of like a debug output, just to make sure that, you know, if this came out a different color, then I definitely did something wrong. So that's that's what that's there for. And as you can see, that one's the same over here as well. So we're splitting them into the RGB components, and you're gonna understand exactly how this works, like maybe with one sentence. So basically, I built this gradient to have 16 segments in between, or 16 spaces in between. Steps, 16 steps. I think it's 16 or 17, I don't know. It's some arbitrary number. So the basic idea is then we take the RGB values of each color, right, and then we subtract them right here. So I have, I transfer the RGB to black blocks right here, just to make sure that they are painted black, because obviously over there they're painted red, green, blue. And over here I did the same thing, but for white, just that I can keep the order of operations the same, relatively speaking. It doesn't matter which one's black, it doesn't matter which one's white, because all these numbers are all that I need. I just need the difference to be the same. So what am I trying to say? I need the right side red to be minus the right side, or the left side red, right? Right minus left for R, G, and B. It can't flip around randomly and do left minus right. So that's why I need this side to be white, this side to be black. For sure, 100%. Okay. So now that I have all of this, this is the difference. This is the difference between this final RGB and this initial RGB. So the total difference is what I'm saying. So let's say that, let's show you for a second. We're just gonna grab this. This RGB is 25, 231, 83, mostly green, but a little bit of red and blue in there, right? This one over here is 1062 and then 226, obviously mostly blue, but a little bit of other colors in there too. Okay, so this right here is the difference between those two numbers. Let's do the red again first, just to, because I already forgot what the numbers were. 10 is the first red, and we're doing 10 minus 25 is negative 15. Sure enough, that's what it is. It's negative 15. So yeah, with these total differences, like if we took these RGB inputs and we just did red minus 15, then we'd end up with the red value for this thing, right? That's how it works? I think that's how it works. I already forget how it works. Anyway, long story short, we have the differences between the two colors. Now, I mean, these are just going to carry us from one color straight to the next color. But remember, we have an arbitrary amount of steps in between. So for that, we actually just want to take these values, these different values, these complete different values, and we're going to divide them by the number of steps that we have, which I just have in a counter block over here. And I'm pretty sure it's 16 or 17 or something. Oh, It's divided by 17 because I have 16 steps. That's why. It's so that this block and this block are actually the same thing as the inputs. Otherwise, if I divided this by 16, then this block would equal the like these blocks would be the same, but then this block would be the last step of the gradient before it reaches this input. So changing this to 17 instead of 16, there's actually 16 blocks up here, but changing this to 17 is what makes this last one the same thing as this input block. Oh my gosh. I really didn't plan any of this explanation, if you couldn't tell. Durf, how long did this take to build? Not that long, actually, because I already knew how to do this stuff from the recent hexadecimal video. And, you know, I think by now most people get how this thing sort of works. So, like, ignore the test modules on the side. You just have an input on each side. You get the difference. Divide the difference by the number of steps you want to take. And then for each step, you have to create your RGB. That's why there's so many blocks right here. There isn't really a way to do it with just single blocks, so you need 6 blocks per color step, which is kind of annoying. There might be a way to do it with the single number inputs, but like it's kind of pointless to do because you just need to do the conversion, which just takes more blocks anyway. So it's kind of pointless. Anyway, a lot of you probably understand how this works already, so really how long it takes to build is just how much work you're willing to put into it. So, because like I could have built this gradient, you know, this size, just like a few blocks over, right? But then that wouldn't have been very fun, and I could have easily not included any of these tests on the sides or this readout for the color. So yeah, I don't know. It just like it didn't take It didn't take as long as a typical live stream does. It was faster than a live stream. So yeah, we have again, sorry folks, we have the difference. The difference, this is the increment value for the size of our steps. So if you end up building a gradient that's even larger than this or smaller than this, just keep in mind the number of steps that you actually want to take in your gradient, because then you're going to divide these difference values by your steps, and then this is the increment. So why am I calling it an increment? It's because you're going to start from the first color value, which is these RGB. You can see they're connected to literally everything here. Yeah, they're connected to everything. So you're starting from they're connected to all the additions on top. And then underneath there's a bunch of multiplications. Just like there's just 3 by 16 additions, and then underneath there's 3 by 16 multiplications. Again, each for R, for G, and for B for each of the color steps. So I know it seems like a lot, but just bear in mind that we're starting with the initial color, tossing them into the additions, right? So we're starting from the first color, then we're taking the increment, and we're tossing it into the multiplication, and we're multiplying it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, the number of the step that we're on. So we start with the initial color, we multiply the increment by a value of 1, or I guess in this case I think I'm starting on 0 to make these colors the same, but we can pretend it's 1 for the explanation. Alright, so we're taking the increment value, multiplying it by 1, so it's just we're taking the increment value and adding it onto this block. So for the first step then, we've just gone by this increment towards the new color for each R, G, and B. So then for the second step, it's the exact same thing. We're just tossing the initial color into the addition, and then we're going to add in the increment value, but this time times 2. And then times 3 for the third step, times 4 for the fourth step. So it's just how many increments are we going to move from this original color towards this new color? And, you know, again, this is just like these numbers divided by 17. So obviously, negative 15 doesn't divide so nicely into 17, but the RGB block just ignores decimals, thankfully. Thankfully, I don't have to deal with that. Can you live build a 5-long sample to make it easier to understand? Sure. Yeah, this has only been like a half-hour live stream so far, so... And that's pretty much it. That's pretty much it at this point. So then each of these final additions serve as the RGB inputs for the gradient display. What's your favorite color in Skrep Mechanic? My favorite color. Well, I don't think I've gotten a blue screen of death from Skrep Mechanic yet. Alright, I'm gonna need a bunch of stuff. Bunch of stuff. Alright. Building a gradient. 1, 2, 3, 4, 5. There's gonna be the input. There's gonna be the other input. I'm gonna need conversion module. Again, if you haven't seen the hexadecimal number logic video, you're definitely gonna want to see that. Also, hello, YOLO Swag 412. Durf, can you make a tutorial about clock with the mod pack? You know, that's something else that I can build this live stream too. I can build an analog clock. Kind of the easiest things to do. Durf, is it hard to make a lerp block? Lerp? The heck is a lerp? I remember it being like a function or something, but I don't remember what it was. So I hope you're following along, because I'm building the gradient thing right now. The 5-step gradients to, you know, hopefully make it easier. Alright, hold up. Do I actually have that connected straight into the, Okay. It must not matter then. Alright. There we go. Is a function where you input the start number and the end number. After that, you give a time number between 0 and 1. So you just want... that doesn't actually explain what lerp is. Anyway, we're gonna take the final number, do a bunch of stuff. Do bunches of stuff. This is wrong. I also need this. We're gonna make this a value of 255 or 6. I mean 256. And we're gonna paint that black and connect it to every division and modulus function on this thing. Yeah, because we're taking those number inputs. Again, you just gotta watch the hexadecimal number logic video to understand what these things are doing. We're taking the big number, we're converting it to RGB inputs, or outputs, I should say, from from one single number to 3 color channels, which should be in this direction. So if we go ahead and paint this guy red, this guy comes out red. Paint this guy green, this guy comes out green. Alright, so R, G, B. R, G, B. So now we have the RGB for 2 colors in white blocks and black blocks. And we're going to go ahead and get the difference value between the two. Now this difference value, again, we just need to multiply it. I'm gonna need to move my display. Alright, so we just, what am I doing? We're not multiplying, we're dividing. And we are dividing by exactly 1 more than our the number of steps that we're displaying. So for me that's 6, because I'm building a thing of 5 long. Alright, so then RGB. So now we have the increment value for our display up here. Okay, now the increment value, again, we just need to take... Ah, jeez. Okay, now comes the lame part. But we're gonna do it one by one, so that you can see sort of what's going on. Alright, so that's a value of 1. Get rid of this. We're gonna connect you to every single block. So now they all have 1, except the first one has 1, but this one now has 2, this one has 3, 4, 5. Okay. So now, for each of these, you have to take R, G. Oh wait, these are in the wrong order. Whatever, it doesn't matter. R, G, and B. So now it's going upwards. R, G, B. Anyway, we're taking RGB and we have to multiply it by this thing, which should just be 1. So now, what this column has inside of it right now is the increment value that we just calculated down here times 1. Except we can't, I mean, we can just put that into the block, but that's not the color that we're going to come out with. Or that's not even going to be close to, it's going to be very close to black, actually. Yeah, see, and if anything, it's just closer to green. Because these increment values are just the difference. How much we're going to add on to this color to move it towards this color. So this is just the difference values. These aren't actually moving this. We have to start from this color, not from black, basically, is what's going on. Anyway, what I was thinking of doing was the same way I generated like 1, 2, 3, 4, 5 here. I could start with the difference values and then like continuously add them to each other to get essentially the multiplication things down here. But that's just gonna it's gonna end up being 3 more blocks total. It's kind of silly. Yeah, so nothing that I can really improve there. Anyway, so we slapped on... this is the really lame part about playing with number logic. And, you know, I still haven't learned my lesson. I still haven't just installed the small connection dots. But anyway, we gotta... oh, gosh. We gotta connect... we gotta connect this one out here. Those multiplications back there, they need to be connected in front. So yeah, this is, again, like, probably the only really lame part about playing with number logic. But aside from this, like, if you know what you're doing and if you can just focus and keep track and... okay, cool. And not mess up, then yeah, then it'll do just fine. So the R starting value goes all on the bottom. Which, by the way, who asked who asked for me to build this live on stream? You better have been watching this whole time and learning. Because we're finally getting to the point where we're going to connect our, the display blocks on top, and then you'll see the gradient logic. Alright. R, G, B. R, G, B. R, G, O, B. B. So yeah, as you can see, the last color there is the exact same as the input color, so I'm just going to reduce this by 1. I mean, it should have... clearly doing something wrong. One, 2, 3, 4, 5. That should be it. Okay, maybe it just looks like the same color because I can't tell the difference between several shades of green, apparently. It looks like it's the same color, I swear. Hold up. We can just we can test this. There you go. Are they equal? Bam. They are equal. What? So you're supposed to be one more then. I think so. I confused myself like there and back. What I learned. Ooh, pretty colors. Well, anyway. So yeah, that's a complete build from start to finish for 5 steps along the way. So as you can tell, as you might be able to tell then, building 16 steps is the exact same process, just slightly more tedious. And this thing I'm going to put on the workshop so that you guys can, you know, play around with this test, play around with these different tests like this hue rotation test. So I'm gonna leave this on the workshop. This is the exact same thing, except it's it's just the inputs and just a 5-step display. Yeah, a simple version of this. So I think the useful part, the thing that people are really gonna want out of this is probably the ability to grab colors out of any gradient. I think that's probably the main motivation for me building something like this, is because like a lot of people don't know how the color stuff works, even though shoot the RGB blocks to have random colors. Yeah, that's something that you can do. But yeah, sometimes like people don't understand how to make the color that they want to make, even though I've made videos explaining how to do it. And people still don't watch them. They don't leave likes. They don't leave comments. Arrgh. Nah, but I think one of the main things about this is like, say you want this sort of very peachy color. Blam! Now you can get the color code for it, or just like extract it to other RGB blocks. But there's the RGB, and you can save it to a memory panel if you want. Just extract it out of there, save it to a memory panel, or remember the numbers if you want to use it for something else. So if you actually wanted to, you could create right here. Boop, boop, boop. So if you wanted to build numbers for testing, it's as easy as that. And what was that? Oh, shoot! now my color's gone. I wanted to see those RGB values. Huh. Well, that's lame. But yeah, another... Well, anyway, you can just, you know... do you know, build whatever colors you want. Another thing that you can do... where is it? Where is it? This guy. So this smart sensor, you might know that it does have a color mode. There's no real indicator. Okay, it's in color mode. Cool. So yeah, the color mode that it has, you can extract any other color out of the gradient, sort of like that. So if you know, if you wanted to use this gradient thing, this gradient tool, let's say, as part of your build, or maybe you want to have like some kind of password protection or something, like a lock on your door, and all you have to remember is 2 color inputs. 2 inputs, I guess. Or 2 very large numbers, or 6 numbers for RGB. And then if you can have like an array of sensors, or like a key card reader, or like a barcode reader type of thing. So a bunch of these sensors to check if the color equals another saved color. And just from you remembering 2 inputs, you can define like a code, so to speak. And of course, if you flip your sensors the wrong way, then it's going to be reading it the wrong way. And I don't even know. What's the point of creating a color key to open a door? It makes no sense. But anyway, yeah, I think I'm gonna put this on the workshop right now, actually. RGB block gradients. Cool. I even typed out a description already. Cool. I am a smart boy. Building something for a video that I'm going to record and then never record it and then only live stream it. Smart boy Durf. So yeah, that's on the workshop as RGB block gradients. Durf, what is your favorite color in Skrep Meknik? You already asked me that, and I was like, I don't have one. Or maybe I didn't say that, but... Give me 2 seconds. I gotta make sure I have the required mods listed. Durf, if you connect a light with the RGB block and lift it, the light only has a normal color from the RGB block, but no light. Can you fix it? No. It's something that it doesn't need to be fixed. Don't ask me to fix something that doesn't need to be fixed. Oh, that's Sometimes I laugh at the answers that I give for reasons that probably no one is aware of. I have an audience of 11 other people inside my head, and they laugh at my jokes. Unlike some people. I think I have I don't even know if I have polygons in here. I'm just gonna, you know, as a matter of fact, I don't even think I'm pretty sure this only needs the mod pack. But whatever, I'm including the top 3 mods, because that's pretty much what I build with these days. Alright, what was the question? Oh yeah, the RGB light thing. RGB. Lights, doesn't really matter what kind of lights. Lights. Alright, so, doesn't help that there's a bunch of stuff behind on the other side of the wall. So you connect the RGB block to a bunch of lights. And then you're like, hey, where is my light? Oh my god. Oh my god. Alright, we'll just go RGB. Set it to some color. Except I'm going to make it oh, where did I just connect you? Don't go to the wrong thing, please. There you go. We're setting it to hue saturation value mode. And that is, oh my god, you're wrong. I just connected it to something I wasn't supposed to. There we go. So now, yeah, so the question that you had was, the lights are changing colors, but now the lights aren't even on, right? I'm pretty sure that is this thing right here. Gotta paint this white. So it's another logic input. There you go. And that's how you can turn on your RGB lights. And for those that are seeing this for the first time, this feature, let's call it, works with any lights in Skrep Meknik. There you go. It does look a little bit weird that, like, the frame of the light is also being painted different colors, but, you know, for the modded lights that just have, like, a neutral color for the frame, then it definitely looks better for RGB lights. Yeah. Nick saying, we already fixed it like a week ago, but I have no idea when we're updating the mod. Well, as you can see, Nick, it's updated. It's in there already. It's already publicly updated. Everybody should have this already. Although I'm waiting for Brent to fix another error with the RGB block. He still hasn't done it. The freaky deaky guy. I mean, I have an entire build waiting, just sitting there waiting, and it's, you know, just waiting on an updated RGB script. That's all. Yeah. All right. So I updated. Wait. Did I? Yeah. I uploaded the thing. I uploaded the what I call it, RGB block gradients or something like that. Good luck you with Brent. I know, right? No, I'm gonna maybe I'll force Nick to do it. Cause damn if I'm gonna do it myself. That's funny. Can you please build a RGB car, please? No, you can do it. You can do it. Get Skrep Meknik, get the mod pack, and get the RGB block. Look. This color changing thing, it's just these 3 blocks and a switch. It's not a big deal. And there's also some some tutorials on Scrap Mechanic mods. So you can do it. I believe in you. I believe in you. That's worth something, right? Alright. So, I don't know. I don't really know. I guess I'm going to end the stream early as well. 2 kind of very lame streams today. But some of my... No! No! All I see are his insides and his eyeballs. Oh, no. No. We gotta load into this world. Please don't crash on me, Scrap Mechanic. Please. Hold on. I gotta wait. Does this update also have the updated block spawner script? I don't know, Nick. You guys, you and Brent are the ones that are updating the scripts now, Nick. Right? Don't ask me, because I don't know. I don't know what you guys did. Ask Brent. And then finally you'll understand why I'm frustrated at him so often, because he just doesn't do anything. And you have to remind him like 50 times before he's like, yeah, but you're uploading without even telling... Well, I mean, if there's an update, I'm gonna upload it. What? I don't know, man. The answer to the question is I don't know. Anyway, don't crash on me, Scrap Mechanic. Please don't crash on me. It crashed. Just leaving the world crashes. Which is really shitty because now I can't go back into it without having to fix it. You know, this one error is probably going to be the reason why I stopped playing Scrap Mechanic. Not even gonna lie. I'm kinda sick of having to constantly fix this DB journal error. All because I just wanted to load in the same world with a different mod. Oh boy. You don't have Scrap Mechanic. Dude, you gotta join the giveaways. I'm doing a giveaway for Scrap Mechanic on my second channel. Make a batch file to do it? Nope. Nope. No. I shouldn't have to. That's that's the problem, man. I shouldn't have to do any of this extra work. Axolot could just not be bad. And, you know, that shouldn't be something unreasonable for me to request either, right? Like, it's a reasonable thing to assume that game developers are probably going to prioritize taking those, you know, those things out. Modpack beta, modpack polygons. Pretty sure that's it. All because I just wanted to load in this world with a giraffe. Even though I have nothing to do, might as well just end the stream. The mod pack causes it. Nah. It's any mods with scripting basically cause it. What's your second channel called? Oh, it's not like it's linked in my channel page or description or anything. Oh wait, it's actually not linked in my description. Here, I'll type it in the chat. It's just Scrap Mechanic mods, like 3 words, Scrap Mechanic mods. I'm pretty sure you guys can find it. Alright. This is all I wanted to do. I just wanted to load in this guy. Probably my favorite build today. To date. My favorite build to date is a modified version of the original giraffe, but this is one with natural AI. It'll just sort of roam around the map on his own. looking all cute. But then if you, you know, run up to him all aggressive like, then he'll start running away. And he'll try to avoid you. Except for failing completely at it and just running towards me. There we go. Now he's running away. Yeah. Their sense of awareness is not the best, but as you can see, he already doesn't see me anymore. And he already calmed down. So yeah, you can herd them around the map. This is something I built on another live stream if you guys want to check it out on my channel. I think I just called the live stream "Have You Heard?" because it's all about herding giraffe. And I also show the original giraffe builds in there too, with like the one with the stretchy neck, and the other versions of it too. But yeah, I really like you got to see that stream too, because like I spawned in like 5 of them or whatever. And some of them were just like roaming around the map on their own, and they traveled such long distances. Durf, can you change the range of the giraffe from 60 blocks to 69? Sure I can. I'm not going to though, but sure I can. All right, let's bring the giraffe over there. I don't know what over there is, but we're gonna take him over there. Just turn. Just don't run into the... Oh, come on. I wanted you to go in between. Come on. You can do it. The problem is when he gets so startled like this, he ends up, you know, popping those wheelies. Hold on, I gotta give him a sec to fix himself. There we go, there we go. There we go. There we go. Now we can make some good progress. Yeah, he's not popping too many wheelies. You gotta be an expert. You gotta be an expert giraffe herder to really know how to work these guys. All right, well, I think that's it for the stream, guys. I don't know what else to do anymore. I hope you guys like the RGB gradient thing. It's something that nobody asked for. But you guys let me know by hitting the like button if you want to see more, or, you know, in the comments down below. Actually, do leave your comments on this stream VOD for something else that you want to see me explain in number logic. Like if you wanted me to show you how to do something else besides gradient. RGB giraffe. Rado, why are you even allowed to speak? Sometimes you just... No, the problem with that, Rado, is that I don't have RGB polygons yet, so I can't get this nice, smooth definition that you see on his back over there. Right? So I gotta wait for the RGB polygons. Do it now. No, I refuse. No, I gotta wait for the RGB polygons to exist. First of all, that's something else that people have been asking for. Gotta make the entire polygon set out of RGB, and then we can have RGB giraffe. And funny enough, I can even make the because these are the same hue, I'm pretty sure, the brown and the orange, they're the same hue, just different saturation and value. So I can basically make a hue rotating giraffe that still has the spots, and it'll look the same for every color that it's on. Yeah. Anyway, I think I scared this giraffe a little bit too much. He's wanting to get stuck in the corner. Get out of here. Get out of here. Stop licking the tree and get out of here. Oh no. Oh no. Get out of here. Alright, he's good. So yeah, make sure you hit the like button. Make sure you leave your comments on this stream VOD if you know, for anything else that you want to see me explain with number logic. You know, I thought about doing a bunch of tutorials So on the Skrep Mechanic Mods channel, which by the way, the giveaway is going to be on the discussions tab, like the community tab, where you see all the community posts. Mr. Yamaha, that's where you want to look. But yeah, on that channel too, I have tutorial videos that explain how these parts work. But those videos don't actually give you, they don't give you very many examples on how to use these parts. So on this channel is where I'm showing you guys how to use these parts, like tank drive systems, camera-controlled airplanes, and pole-climbing robots and stuff. So again, leave your comments in the stream VOD of this for other ideas, other other explanations or whatever. Can you please do like a floor that moves with you in all directions? You mean like the piston auto floor video, but in 2 dimensions? Yeah, I could do that. That's on my list somewhere. It's on my to-do list. But if you really want me to do it sooner than later, you gotta leave those comments, because I check every day or every time that I do something on YouTube anyway. I check my comments, right? So, if you comment more often that idea, it's gonna remind me every day, and then I'll be more likely to do it sooner. And I know that's a really weird way to explain it, but somebody suggests something to me once, and I'll put it on my to-do list, and then I get other suggestions, and I end up putting those suggestions higher up on the to-do list, just because I get those suggestions more often. So things get pushed down a lot on the to-do list. So yeah, leave those comments if you definitely want me to do your ideas. And that's gonna be it for today. How's Giraffe doing? How's little Giraffe doing? They can't climb up hills very well, so going down here is basically like a death sentence to Giraffe. Anyway, that's gonna be it. I'll see you guys next time. Bye, everyone.